Cool. So I'm Jean, and 2020 was my first year attending this conference virtually. At the time, I thought we were building an API spec product. And since then, in the last 2 years, I realized API specs are so much more, and our product is so much more. So this talk is going to be about all of the surprising uses for API specs that I've learned. And the biggest one is that API specs aren't just written by humans for machines, but they can be really useful the other way around. And this is my first talk that I'm giving since 2019 in person, so this will be a very interesting time. Yeah, so like me, you probably think of specs in a certain way, which is you write a spec for your system, and then you build the system, and you make sure the system adheres to the spec. I mean, before I came to work on APIs, that was pretty much all of my work. I'll get more into that. But then I went down the rabbit hole of trying to build a tool that told developers what their system is actually doing. And the more I dug, the more I discovered that most teams don't know what their system is doing in production. And it's not only that, they don't have a way of knowing that. And if that's really the case, how are you supposed to know if your spec is right or not? And so this was the central question that really bugged me for many, many years. It led me to spend a lot of years working with API specs. And that'll be the main topic of this talk. And I'd love to hear from all of you, actually, because this is the community to talk about this. I'm coming here to solicit your thoughts. So this talk is, it's following on what Frank said. It's about how API specs are really this magical thing. I mean, I think APIs are the nervous system, the connective tissue, whatever body analogy you want to make. And API specs are really kind of what ties everything together. And the main point that if you take away one thing from this talk, it's that people are thinking of API specs primarily as a human-to-machine or machine-to-machine thing. But what do we open up if we think about API specs the other way around? And I know Aiden here is also working on some of that stuff, but I think that API specs are really powerful for communicating to humans. And so, what does this open up is a question that my team and I have been thinking about. So I'll just start with something I've talked about for a couple of years now. So, if all of you are like, Jean, we've heard you talk about this for many years, I'll just fast forward. But there's been a growing gap between spec and behavior in the industry in the last decade or so. So I'll just set the stage by saying, this is my view on that. Then I'll talk about how we came to auto-generate near real-time API specs. This was really, we started out building something very different. Then we realized this was the crux of everything. So we deduced that APIs were very important from everything we were doing. And because we didn't really set out to build API specs, we're just kind of like, okay, what are people going to do with this? And so we came upon some surprising uses, unexpected uses for these API specs, so I'll talk about that. And I'd actually be really curious to hear about what you've seen too, during this talk or after. And then because it's such a weird thing to do, I'll just give a quick couple of slides on our engine for near real-time API traffic analysis. So this, could be many other talks. Mark on our team is giving a talk at P99Conf just about this one time he reduced memory usage. But I'll just give a quick overview for the nerds out there of okay, this is generally some of the challenges we solved. And I'm like I said, this is my first in-person talk since the beginning of the pandemic. So I don't know how much people want to interact anymore. But if you have things to say, just shout them out, and we'll see how things go from there. Cool. So I figured instead of giving a bio, I'll just give a short history of my ASC presentations because it really shows my trajectory through here. So for a little bit of background about me before I came to work on APIs, I was previously an academic, so I was a professor at Carnegie Mellon University. I was working on a very different kind of spec. So I was working on how do you prove that programs do what they're supposed to do, which is, in some ways similar, in some ways very different. And from working on that, I realized, wait a minute, everything's calling each other across APIs and we can't prove anything. I should probably just go work on that instead. So that's the very short summary of how I came to work on this. I'll get into more how we came to auto-generate API specs, but in 2020, we started out, we had been building something else. We had to build a spec generator as part of it. We realized that a lot of developers asked for only the spec generator, and people were like, the other thing you're building is fine, it's cool, but we don't really need it. Like, we need the spec generator. So I showed up, I talked about that. I met Aiden virtually, who's also working on that. But where we knew we wanted to head the whole time was we wanted to do something around helping people understand their systems better in real time. So then we're like, cool, like the spec generator is very useful. It's very interesting. This is very unexpected what people are doing. We were running in tests for a while. I'll talk about some challenges that we hit there. But since then, we've moved to using specs as kind of a backbone or an intermediate representation for understanding what's going on in these systems in real time. So you can see in 2021, we started being like, okay, this is how we understand actual system behavior better by running in CI. That was where we were as of 2021. And then this year, the big milestone we hit was we started running in production. And so the big thread through all of this is API specs. We thought they were kind of a stepping stone for a lot of other stuff we wanted to do. And they've become very central. They've become very important. And and I think that this is something that you all appreciate and know about aspects of much more than I do. So I'd love to hear from all of you about it. So yeah, I'll start with the growing gap between spec and behavior. If you've seen any other talk by me, I open with like 5 minutes of this, so apologies in advance. This is not going to be very interesting for you. But yeah, this is a variation off a slide I gave last year at ASC, but I was like, this is such a good analogy. I just used it for the rest of my life. It's really hard to come up with analogies. But yeah, so traditionally when you think of specs, they're really like planned gardens, they're top down. The intention is for everyone to agree on what to build beforehand. And the kind of specs I was dealing with are like you're building an operating system, you agree on what the operating system is going to do, you agree on what it means for the scheduler to be correct, and then you go and you prove that the system is actually doing it. And API specs in some sense are not so different. You plan everything ahead of time. You're like, all right, this is the interface between us, this is the behavior. And on the one hand, I'm not saying don't plan. Having a plan is better than not having a plan. But I think there's a lot that gets in the way of knowing that your plan is going to be executed the way that you think it will. And so there's just a lot that happens after the plan gets made now. So the big thing that sort of got me away from proving the correctness of specs and working on some other stuff was I just kept thinking about code bases are really big now. And so like, you can't really see the details of this code base or of this image, and it's a really old image, but the main point is that, software code bases are like bigger than DNA. Like there's just so much software out there, and it's gotten very different from, I don't know if people read like the books from the 80s from Bell Labs where, they're like, we were passing around these 10-line programs, and the 10-line program took us like 2 weeks to write, and we're like, aha, like this is not that anymore. So we're living in a world where code has a life of its own. Like your oldest commercial software is like, older than me for sure. But there's like the code has evolved. It has a life of its own. It has emergent behavior of its own. And so that was the first thing that got me thinking, wait a minute, like maybe going around and cleaning up software by like, doing everything with specs and proving them, that's not really the way to go. And then the other thing that really got me thinking was just the rise of microservices in general. And so like the world I came from, it was very much about if everyone just used the right programming languages like Rust and Haskell and all of that, life would be better. But something that I kept thinking about was if you're calling across the network to something else, like all of your language and runtime guarantees get completely subverted. And so like this, I don't think everybody thinks about life this way. But there's like, microservices really throw a wrench in a lot of these things, and you kind of have to really just embrace the dynamism of your systems. And then there's just the rise of APIs, and that's what I expect a lot of you, that's the world you live in. But even if you had like complete control over your microservices and complete control over your code, you cannot control what a third-party API you're calling does. And so, side note, a lot of the users we work with, they're like, all right, like the place where APIs are really getting us is when we call out to third party and they change their functionality or they roll out new code and something happens. It's impossible to kind of spec out everything that happens. It's impossible to really communicate about everything that might interact. And so you really have, again, this is this analogy I've been using since last year, so sorry again, I really like it. But modern software is like this organically evolving rainforest. So you have creatures coming in, coming out, you have trees getting born, trees dying. I don't know if trees get born. But it's easier than ever to add and change functionality. Like you just have to bring a thing into or out of your system. But on the other hand, you don't have that kind of order anymore. You can't think about your system in a top-down way. And so implementations depend on how components fit together. So any interface that you put yourself as responsible for giving to the world, like you're on the hook for something that is super dynamically changing now. How do you make sense of that? And then a couple other things that have happened is, I think a lot of you probably will say, I still test and test. I have good integration tests. I'll say you're probably in the minority. A lot of teams that we talk to, they'll be like, Gene, I have a secret. Our tests are not so good. And I'm like, I'm not surprised. Don't worry, no shame. This is like every team out there. Also, I watched a talk at one point that I thought was really interesting where the people said that their intended behavior, so I think they were doing authorization or something like that, which historically, if you're like, who can actually see my thing, you think of it like you write some rules, Sally can see my thing on this day and Joe can see my thing on this day. But no, their system was so complex, they were actually doing authorization based on their observed behavior, which some of you are nodding. This maybe is how it happens in your systems too. This is actually how I've seen it happen all the time. But we really reversed this really top-down, spec-first way of programming in general. And so what does that mean for software has been a question I've been spending a lot of time thinking about. So again, I've been saying this for a while, but I think, every time I say it, people have really interesting responses. So that's why I keep saying it. So this brings us to the story of how we came to generate these API specs. So so all my pictures that are like not Akita specific are either Taylor Swift or from the Odyssey in this talk. So the Odyssey is a new one. I was just like, I got to switch it up from Taylor Swift. Fun fact, there are actually very few like commons pictures of the Odyssey. Most of the good pictures of the Odyssey are not commercially licensed. Anyway, but really quick rundown of how we got to API specs in the first place. So we actually started out with the goal of being like, okay, there are a lot of microservices. Security teams need to see their data. That was actually like one of the focuses of my research in academia. How are they supposed to see their data, their sensitive data, and their APIs? And so we're like, okay, so we have to be black box. Like we have to go from the outside. They're worried about their APIs. We should probably build a fuzzer. So we're like, cool, fuzzer is very standard. All you need is an API spec. And so we went around, we like built this little fuzzer demo. We had, we demoed it to people. People were like, wow, this is so cool. Like, what do we need for it? We're like, all you need is an API spec, which we're sure you have. And so then we had our first user. I think they spent like 3 months writing an API spec so they could use our tool. And we're like, do you have feedback? Do you like, any feedback? And they were like, yes, if we have to write an API spec, we cannot use your tool. Like, this does not scale. And so we were like, well, gosh, like we really liked what we were building, so let's build an API spec generator. And we're like, how hard can it be? And so again, we had a certain constraints. They're like, you have to be black box. Like it was a security team, so they're like, you have to come in from the outside. We can't change any code. People get mad at us. Like we can't install proxies. People get mad at us. We're the security team. Everyone hates us. We're like, okay, cool. So we like went and built, and we're like, okay, here you go. So like it's completely like black box, drop in, passive, BPF based. Like we just generate an API spec. And they were like, wait. So like you could do that. And we're like, yeah, like you told us to build this, like we had to build this to do the other thing we want to do. And so like what we realized was the fuzzer was like interesting, like that was cool, but like this is actually very helpful for many other reasons. And so like what we realized was that like one, the assumption we made that people just had API specs laying around, like not the correct assumption about life. And then two, like there was lots of other information that people wanted about their systems that they were not getting, that these API specs gave them. And so, like, you know, when I say popular, like, you know, it's like startup popular. Like, it wasn't like millions of people are like adopting it immediately. But, you know, there was definitely enough interest that we were like, there's something here. Let's just see what people are gonna do with this. And so, so this brought us through ASC 2020, which I was like, okay, like, well, now that we're doing API specs, let me show up at this API specs conference and see what's up. And so this is actually a slide directly from my ASC 2020 talk, where you know, like I was like kind of starting to grapple with the realization that, like people really like these API specs. And so some of my conclusions there were people generally know what to expect in an API spec. There's like a nice standard format. API protocols were designed for humans to read and edit, so why not just have humans read and edit them? And also the fact that there weren't that many API protocols was really exciting to me, because I was like, maybe this is like the intermediate representation or like the lingua franca of like understanding with machines. And so like at the time what we had discovered was people were just reading the specs we generated to be like, what's going on with my system? And so like that was like I think one of the first, like I guess the second surprising thing after we realized people don't have these specs. But so we're like, okay, cool. Let's see where this goes. Like, there's a place we want to end up eventually, but you know, sure, we'll go at it this way. And so at the time, there was a set of things that we thought was going to happen with these specs, and like most of them didn't happen. So I'll talk about that too. And I'd actually be super curious to hear about, you know, your thoughts on this too, because we have one version of it. So in 2020, we thought what was going to happen was, you know, we're just going to use these auto-generated specs to shift everyone left. So we had a CI integration where like people are going to learn about their production behavior by running a test. People are going to catch breaking changes early. People are going to understand their test coverage, like they have like the specs in their head, and then these are the auto-generated specs, and then people have intended specs that they want to understand drift from. Because like in the beginning, people showed up and they're like, this is what we want, can you build this for us? And we just, you know, we started building. We're like, cool, you know, here's some integrations, here's some other stuff, and spoiler alert, like almost none of these things happened the way we thought they did. But API specs are still very useful. So some obstacles we encountered here, people just didn't have very thorough test traffic. So we'd be like, okay, run here. And they're like, why am I not seeing anything? We're like, well, like you tell us. We're pretty sure our thing is working. So two big challenges we kept on running into was not enough test traffic and test traffic not going through the network. So we actually spent like a bunch of time building like random framework integrations where we were like capturing like mocked up API calls and all this stuff. That was just like a giant rat hole, I would say. We spent a lot of time building this, and it didn't work super well. Also, specs alone didn't seem to be enough. Like once people got the spec, they're like, we want more now. And then like the stuff in test just ended up being really noisy because people there wasn't very much in test. So then I showed back up in ASC 2021. I was like, all right, guys, here's the update.
Recording in progress.
Oh yeah, that too. So we're doing up-to-date API models. So you know, like we're starting to try to run in staging and prod. We're giving people kind of like spec exploration. People want that. We're still diffing them against handwritten specs. We're still diffing, you know, specs across pull requests, but I would say like 2021, we were like starting to see the cracks. We're like kind of got to do something else soon. And so like this is a slide from ASC 2021. We're like kind of in the middle of being like, how do we get to real time? Like that's where the real traffic is. And so where we've been headed since then is like, well, we've just like kind of had to shift further right. That was where we wanted to go eventually, but we're like, well, test is so clean, it's so easy, maybe we could start there. Like, ever since we were like drop us in staging, drop us in prod, that's just been like, people are like, oh, finally, I see all my endpoints. And we're like, oh, yeah, no one has good tests. People also were like, okay, you know, like, so this probably won't make any sense to people who aren't static analysis nerds, but they're like, seeing every possible API endpoint is not that interesting to me. That's kind of like, you know, static analysis tells me everything my program can do. What I want to know is like, what are my most used endpoints? What are my least used? What are my most errors? Things like that. So we started building more like performance, latency, that kind of analysis, and then that started pushing towards real time as well. And then one thing that we've also started shifting is, in the beginning, people wanted, like, we thought people wanted reports. So we're like, here's your spec, here are your changes. And they're like, wait a minute, this is not correct, this is not correct, that's not correct. And so we realized that the API spec really is like, just has a lot of information, but there needs to be like different projections onto that spec that people want to know. And that's really, you know, like the communication can't just be like, this is everything you might ever need to know. There need to be summaries, and those summaries, at least like we haven't cracked, like, you know, this is the one summary. People want to have a conversation with the spec. So yeah, I mean, this is, you know, our one set of learnings. I'm super curious, especially like this conversation with the spec, what you all have found. But that's sort of like where we are, like the basis for the other stuff I'll talk about, which is what we learned about surprising uses of API specs and like how our thing fits together. And I'd be super, like, I think that a lot of you deal with specs, you probably do some auto generation. I'd be super curious to hear from you about like what does that look like for you? So I've alluded to most of these already, but I just wanted to sum up the unexpected uses for auto-generated specs, because I think that initially we're like, oh, you auto-generate specs and you feed that into a tester, or you auto-generate specs, you feed that into a fuzzer, and or you know, like not for people basically. But once we put auto-generated specs in people's hands, we're like, like there's a communication need that's here. We don't know if it's specs the way they exist right now, but it's something. So that's something I'd love to talk about. Cool, so this I've been talking about the whole time, but auto-generated specs is the basis for machine-human communication. So, oh, this is a typo, sorry. So we had been helping people, we had been hoping people have specs, not a typo. This is just not true. People, like, you know, I think that most of the teams we encountered, specs are out of date, incomplete. There's something that prevented us from just directly feeding it into something else. And so when we first auto-generated specs, I think people were so excited, they tried to read the whole spec. But I think what we realized was that was just because they were excited. Like, that's not the user experience people want every day. And so we started doing things like giving people the ability to search, the ability to filter. And what we're now after, which I think is still like unsolved by us, and so I'd love to hear from you about how you do it, is telling people what they want to know about APIs they don't know well. And so I think for a while we were like, okay, what do you want to know about your APIs? And they're like some small stuff. And so we'd show it to them, and they're like, but like what we really want to know is stuff we don't know, which is like a super hard developer experience problem. But I think that like it seems like, you know, the reason they were reading the spec is they're like, you know, is there anything catching my eye that I don't know? But that is not what someone wants to do every single day of their lives. So this is, you know, this was kind of a surprising dimension of auto-generated specs that I would love to talk more about. The other surprising dimension was so subtle that our users had to tell this back to us. So like when we first started inferring auto-generated API specs, we thought it'd be something fancy that was what they wanted. Like, you know, here are authentications, or, you know, like, don't you want to know the difference between like different date times? And they're like, that's cool. But the thing that seemed to be really valuable was actually per endpoint abstraction of the API, which is like, I'd actually be really curious to get your view on this because you guys are API experts. But this is pretty hard to get using other tools, and like we confirmed it using some of the tools we use, like Datadog or Grafana. But like so this is going to get pretty technical spec-wise, but. Like if you have like paths like, you know, users 0, users user 1, users user 2, what you want to do is treat that as one semantic entity. But most tools, you have to do a bunch of work to actually group those together to be like, these latency issues are all the same latency issue, or these error issues are all the same error issue. And so like something people told us was like, hey, that part is actually like the most useful thing you're doing. And we were like, huh. On the one hand, that felt really easy, but on the other hand, I'll talk about that's actually one of our challenges, and it's an ongoing challenge because there's just this long tail of heuristics you're burning down to make this work well. But it's super subtle. There's tons of edge cases. Everyone's API shows up kind of looking different here. But yeah, that has been a surprising benefit of auto inferring API structure. And then finally is the change one. So in the beginning, we noticed users were not only were they reading their specs, but they were downloading different specs to diff against each other. And they're like, well, this is kind of our new source of truth. We want to know what's going on. I will say reducing diff noise has been a major work in progress. For us, we realized that actually being able to auto detect the semantics, the endpoints was a huge barrier to doing automatic diffing properly. But change is a big thing people want to understand. I will say spec diffs are I don't think that our users have been liking our spec diffs very much. They keep asking for other stuff. But this has been a feature that we actually reverted to alpha because we're there's a bunch of work to do on making this right. But if you look at any other tool, any other observability tool out there that helps people understand how their systems, change is the next set of keywords. But I think that auto-generated specs can be cracked this problem for understanding change. But this is definitely a thing where humans want to be communicated with. Cool. So now for a very quick look, very quick, at our engine for real-time API traffic analysis. So I'll just set this up with a premise. We wanted real-time API maps, we call them now, without any intervention from the developer. So this is a different set of challenges from most tools. I think a lot of other tools are we're okay with some interactivity with the developer, but we were no, we're building for people with legacy systems or people who have to go in from the outside or people who have no clue what's going on. We want to just take the premise of no touching the code, no knowing anything as far as possible. So can we get away with asking the user to do no instrumentation, no recompilation? A lot of people have yelled at us. They've been that's very limited. Why would you do that? And we're well, for a very specific and large set of people, this is the thing. We also wanted to assume no expertise, and so we wanted to assume this is not a situation where the users are co-developing a spec. This is not an API first situation. This is a dig me out of a very large hole situation. And as part of that, assume no familiarity with the API being monitored. So one of our popular adoptions is I have no clue what's going on, drop Akita in, and then Akita tells me something, and then hopefully we stick. But that was really what we were going after, which is a different set of things than what a lot of people go after. And so I'll just run through a couple of challenges, how we solve them, and like I said, this is very fast. So the first big one was just capturing traffic in a non-invasive way. So how do we capture traffic without too much overhead? So we wanted to not be in the data path at all. We wanted to introduce no additional security risk because we're very small. We don't have the bandwidth to go around holding lots of data and then getting breached for it. So our solution was use eBPF for network packet capture. So this is fully passive. The only additional overhead is the CPU and memory that our agent itself takes. We're not in the data path at all. Depending on how we fit in the AWS tier you're in or something, a lot of users have been surprisingly, this just fits very nicely. But if we're maxing you out, it depends on a few things. But yeah, and then the other thing we do is we obfuscate out the payload data. So this is basically it was originally designed for a security team to be installed with no one noticing. So it's a very, very lightweight. And I'm happy to talk more about this later. Another challenge that we encountered was how do we infer path parameters? So this is the endpoint structure I was talking about before. If you have user 0, user 1, and it's all user, there's actually a ton of complication here. Because what takes precedent? What if you have some things that are parameterized and some things that are not, et cetera? TLDR there's no one insight. It's just a lot of hard work. It's a lot of heuristics, like all the way down. And then the other thing that I think like probably needs to be its own like series of blog posts or talks is like, how did we do this in real time? I asked the team and I was like, hey, so was there one insight? And they're like, nope. Again, just like a long series of like very like, you know, solid engineering decisions. They're like, we got lucky, but I think they made some solid engineering decisions. And the interesting part is we're actually doing this in PostgreSQL. Like we are planning to switch to a time series database, but like we haven't had the bandwidth / needed to yet. Not an emergency, but yeah, I'm happy to talk about any of this. I'll skip the how Akita works slide. You can read that on the internet. But my parting thoughts are, I really believe in API specs. I think they're the assembly language of the API world. I think API endpoints and data formats provide this backbone, this foundation for understanding many other things about systems. I think the big realization for me was API specs go both ways. They can communicate all directions. One thing I would love to talk about with you is the more we don't expect users to write specs, the more useful they can be. So like, what if we thought about specs as a machine-human communication tool? Like, what would we change about specs? And then the other thing is, if we think about something as an assembly language, most people are not writing assembly every day. And so how can we use specs more under the hood for better communication, better system understanding? And so I know I'm out of time, sorry, but my final thing is, my favorite thing about this community is you all are super thoughtful about technology and communication. I think API specs are the thing for communication. So how can we do more to facilitate communication back to humans here? Thanks.